Hey everyone, in this video we are going to solve an important question. The name of the question is permutation in string. So what we have in the question, we are given two string s1 and s2 and we have to return true if s2 contains a permutation of s1, otherwise we have to return false. In other words, return true if s1's permutation is a substring of s2. If we look example 1, we have s1 as ab and s2 as eidba. So we have to check whether any permutation of ab is present inside s2 as an substring. So we have first of all we will check whether ab is present. Ab is not present inside the s2 as an substring, and the other permutation of the s1 is ba. Check if ba is present inside the s2 as a substring. So here ba is present, so we will return true in this case. And let's check example 2. So we have s1 ab and s2 as eidbo aoo. So we have to find the permutation of the ab inside the s2 as a substring. So ab is not present, and if we try to find bo is also not present. We have a substring containing boa, but it is not an permutation of ab. So in this case we will return false. So before starting the question, there are some key observations to keep in the mind. So what are these observations? Let me show you. Just a second. Yeah. Okay, now it's working. So suppose we have string s1 and another string s2, and the size of the s1 is greater than s2. s1 dot size or length is greater than s2. Then in that case we know that any permutation of the s1 cannot exist inside the s2 as a substring, because suppose I have a string abc. Whatever its permutation, its length will never be changed. Its length will always be 3. And if the length of this is 3 and this is 2, then there is no case inside which the permutation of ab exists inside the s2. So here we have to return false. Sorry for my bad handwriting. So this was one of the observation. So what are the other observation? So suppose we have a substring. No, we have a string s1 abc, and we will try to form its permutation. What can be the permutation? acb, bac, bca, cab, cba. We can see in each permutation there is two things common. One thing is that length of each permutation is common, that we have discussed earlier, and another thing is that the frequency of each character will be same. It doesn't matter which permutation we are picking, we will be getting all the character frequency will be same. Here we have 1a, 1c and 1b. Again here in this permutation we will again have 1c, 1a, 1b. So no matter whichever permutation you have picked, the frequency of each character will be same. So how can we use this observation to solve our question? Suppose we are given, let me take this example. This is the example 1 from our question. Let me first erase this thing and then I will show you. s1 is ab and s2 is this thing eidbaoo. So if any permutation of s1 exists inside the s2 as a substring, its length will always be 2. And the length here is 2. So we know that we have to check for 2 length. We have to check for substring having the length 2, and inside that substring we know that the frequency should be equal. Then only we can say that this window from e to y, suppose this window from e to y or index from 0 to 1 have character having frequency same as s1, then only we can say this can be an permutation of s1. But here if you see the frequency of the E is 1 and I is 1, and here the frequency of A is 1 and B is 1, so these are not matching. So we can say that from here to here we cannot form any permutation, or this is not a permutation of S1. Then we will have to move to another window from here to here, I to D, and in this case we have to check whether the frequency in this window, frequency of the character in this window, is same as the frequency of character of S1. Here we have I equal to 1, D equal to 1, these are the frequency, and these are again not equal to the S1. So here we can conclude that this is not a substring, or this is not a substring that is a permutation of the S1. So I will simply just erase this thing and move to another window, D to B, and here if we again check for the frequency of these character 1 and 1, which are again not equal to the frequency of A and B which are present in the S1. So this is not again a permutation of the S1. And then we move to this window, B and A. Here we are getting frequency B equal to 1, A equal to 1, which is similar to here, because here we have also 1, A equal to 1 and B equal to 1. So we can say this can be a permutation of AB, and this not can be, this is a permutation of S1. Okay, so we get our answer. We will return true from here only. There is no need to check further. So we know that the other observation we find here is that we need to store the character frequency of length of the S1, length S1, and if the character frequency of a substring having length S1 is equal to character frequency of S1, we can say that substring present in the S2 is a permutation of the S1. So this was our conclusion. From here you will get the most of the idea how to solve the question, but I will again help you to solve this question in another manner. So now we have one observation, that the size of S1 is greater than S2, that thing. And another version is we have to check in a character frequency manner, and we have to maintain a window of length. Its length will be S1. So so for maintaining this thing, what data structure we can use? So if we have to maintain the frequency of a character, the data structure that first come in your mind is the map. Here inside the map we are given a pair. We have to take a pair kind of value. This is something and this is something. So in our case this will be the character or alphabet, and this will be the frequency. Suppose ABC, and now I am traversing over it, and I have to store the frequency of all the character present inside this string. So the frequency of the A will be 1, frequency of B will be 1, frequency of C will be 1. So okay, now we know that we can store the frequency of the S1 and S2 using the map. Can we further optimize this question? Yes, we can further optimize this question. First of all, let me share why we will be not using the map. Why? What are the drawback? So no matter whatever map you use, either it is ordered or unordered map, the at most time complexity for the insertion will be log n, and searching for be log n. This is the best complexity, and in some worst cases it can be big O 1. Can we further optimize it? Yeah, if we look careful, or if we observe this question, we see that at most we are so first of all what we are even storing, we are storing the character and their frequency. So whatever the string, it doesn't matter whatever the string, it can have only 26 alphabet at max. So we know that we can maintain a frequency array to store the frequency of each character. This will reduce our complexity from big O and searching complexity big O n or big O log n to big O 1, because we know that suppose I have to search the frequency of A, and I have mapped this A with 0th index, then I only have to check for the 0th index which I can do in the big O1. So here we can use the array, frequency array instead of the map, and this will optimize our time complexity. So how to do this? Now we know what kind of the data structure we are using, what kind of the technique we are using. Now how will we actually code it? Before coding, let me give you the flow of the logic, how the code will be flow. We will be maintaining two array. One that will contain the frequency of the character inside the S1. Suppose this is ARR, and it will be at max 26 size, where 0th index contain the frequency of A, 1th index contain the frequency of B, C, 3rd index contain the frequency of D, and so on. And BRR contain the frequency of S2. So what we will do, first of all, we will map the frequency of S1 inside the ARR. So 0th index is for A, 1th index is for B. Let's just map it, and so on. There is no need to map or increase the frequency of other alphabet, because there are no other alphabet present in our example. So this will be 0. And then we will traverse over S2 for just length AB, length which is equal to the length of the S1. Here in this case will be 2. So we will map the frequency of the E to 1. Suppose here we have something index which is storing the frequency of E. So we have incremented it 1, and then I, and then we have to increase the frequency of the I and 1, and then we will check whether these two frequency array are same. In this case this is not equal, so we will not return anything, because we haven't checked for the further windows. Then when I move to this window ID, what I have to do, I have to add the frequency of this D and remove the frequency of E. So I will subtract the frequency of E from 1 and increment the frequency of D by 1. Suppose here is the frequency of the D 1, and then again we will check whether this frequency array is equal to this array, and in this case this is also not equal. Then I will move to this thing dB. Here I will first decrement the frequency of I by 1 and increment the frequency of B by 1. Suppose here I am storing the frequency of B by 1. So in this case B and D is not equal to this frequency array. So I will continue my loop. Then I will be traversing here B and A. I will decrease the frequency of D by 1 and increase the frequency of A by 1. This here, and check whether now these two frequency array are same. So now they are same, means the characters present in the S1 and characters present in S2, not S2, in the substring inside the S2 having length 2, which is the length of the S1, are having same character and same frequency. So we can say that this can be, or this window BA can be a substring which is the permutation of the S1. So we will return true. So this was the whole logic, and because we are using the frequency array, the searching and the insertion complexity will be big of 1, and we are traversing this S2 at max 1 time and AB 1 time. So suppose if the length of the S1 is n and the length of the S2 is m, so the R time complexity will be n plus m, and we know that the m will be the larger string and n will be the smaller string, so we can write it as m plus m, and this will give us 2m, and we can say that this is constant, we can remove constant, so it will be big O m, or the big O length of the S2. And for the space complexity, we will be always using two arrays having the size 26. So big O 2 into 26, this is again constant, so we can write our space complexity of big O1. So this is all about our question. Let me show you code once. So here are base condition. If the length of the S1 is greater than S2, then there will be no case such that S2 contain a substring which is the permutation of the S1. So we will return false in this case. And here we will be creating two array having this size 26, which will be storing the frequency of character present in the S1 and S2. So I have named the first array as frequency of S1 and the second array as frequency of S2 substring. So one thing that you have to keep in mind while giving interview or any other contest, make a habit of naming this variable as meaningful. Don't just write ARR, BRR or any other thing. It is a good practice, and you can this will make a good impression in the front of the interviewer. And this is the size of the S1, this is the size of the S2. We will traverse first at the S1. We will storing all the frequency of character present in the S1 and S2 also, but for only the S1 length. And we will be checking whether these two array are equal or not. If they are equal, then we will be return true. And here in this loop we are traversing over the S2 substring from the S1 length, which is the in our case we will be starting this loop from the here D, because this string for this window we have already computed in the above loop. So we will be traversing from here to the S2 size, and first we have to remove the character which is the present at the 0th index, or the just before the window, and we have to add one more character. So it doesn't matter if your S1 size is 2 or 3, we will have to only add one character or remove one character. And so this is the beauty of the sliding window technique. And if we found that both the frequency of S2 or S1 will be equal, so we will be written true. Otherwise, after traversing this whole loop and we find that there is no substring present in the S2 having the frequency of the character equal to the S1, we will be returning false. So this is our question. Let me submit it. Yeah, it's accepted. Okay, so thanks a lot.